Adam,
Hi.
good morning, or
Or
afternoon, as the case may be.
yeah, evening for
Oh,
some.
yeah, there's a lot of possibilities, aren't there? Are you in England now, London?
Yes, yeah, I'm in London. So just about 6 o'clock in the evening here. But
Oh, it'll be dark, very dark.
it's very dark. Yes.
I was in Denmark and southernmost parts of Europe last month. So I
Okay.
guess when we got to
Right. Of course.
Denmark,
You visited Morton. We spoke.
correct. And you, yeah, that's right. I visited you both. And then we went down to Italy, where the sun has maybe an extra 30 minutes of life.
Yeah.
So have you talked with Morton anymore and gotten him to reform the way dialogue works?
No, that would be too big of a claim.
Okay.
No, but I mean, a lot of the
Okay.
things, you say is things that that resonate with things we know already. Of course, it's always a question of manpower. We're
Mhm.
we're consistently hard pushed to the limits on the manpower. There's so many things we want to do, so many things we have to do, and not enough hours in the day. So
And is that just because the standards are so high for working that dialogue, or are there really not people who are qualified and able to go there?
um I don't know, it's a mixture of things. We're trying to move fairly fast in a lot of ways that require large amounts of work.
Mhm.
um and say all APLs have been lagging behind when it comes to new technology that has come up over the years. And at least at Dialogue, you're trying to catch up on that. But it's like 30 years of catching up, and we're trying to do
Okay.
it right here and now. And so, if you say the bane of my existence is the workspace, APLs
Oh,
have been used to using workspaces since forever. But the modern world doesn't like binary blobs; we like text files. And
right.
trying to make the old system work seamlessly or as seamless as possible with text files, that's the problem. And it turns out it's more work than it sounds like. It sounds conceptually simple. So a few years ago, Morton gave me some ideas, let's do this and this. That shouldn't take too long. So I went completely down under the surface kind of thing. I was gone for a couple of months, and then I came up with a up to the surface again with a prototype, and then we rapidly put that prototype into production. And since then, we've been trying to fix it,
Uh-huh.
and it involves developers being not happy because the amount of work. And yeah, so that's a large amount of what we do. And there's a lot of tooling that's missing, and dealing with the world outside, and formats for data need to be able to read that, and communications and so on,
I see.
interfaces, and the user interface itself. We always have to stay on top uh, of that. Now it's not just a nice user interface on Windows. We have to be able to do that cross-platform, and we have to be able to remotely control APL that's running in the cloud.
Mm.
So there's lots of stuff that you might not think of it as very big, but it's in reality, it's a lot of work that's there. And,
Yeah, and I guess I sort of feel guilty that I don't don't try to take advantage of those new ideas, but I just don't have the time to do what I want to do with the
oh, I mean,
old-fashioned interface.
it's also an interesting dialogue is an interesting position. We do not just milk the cash cow like certain other APL vendors. They're not trying to get any new customers. They're just trying to keep the old ones alive so that they can keep making money off them. Whereas
Mhm.
at least we are trying to cater to newcomers, to make the APL be a relevant option for new people, and straddling that gap and making things more accessible and easier to use while without breaking things for the old customers is easier said than done. That's for sure.
Very good.
So anyway, enough about that. And it is now 6 p.m. in Universal Coordinated Time. And we have a couple of people here, and there might be more coming in. But if you think that the audience here is small, then it's because those are the people that can show up for the live show. There will be plenty of views on YouTube later when we publish this.
Interesting.
So for those that are not in the know, or those that are here, and those who will be listening in later, Charles Brenner is quite something. A forensic mathematician, and possibly the world's foremost such, as far as I can tell, at least. And I suppose APL is the tool that has enabled you to, well, to be that, right? And to come to those conclusions based on the data that you're given, that is valuable enough for, well, for governments to use you to solve their problems. But besides for that, you've also been involved with APL even outside of forensics, right? For
yes,
a long time, since the beginning of APL.
Mhm.
And so I'm very interested in hearing about all that history and all those experiences. You were there with all the big people when all the action happened and APL became what APL is. And then you also use APL for real life-changing work. So blow us away, I'd say.
Oh, thank you, Adám. This is a great introduction. I decided that maybe the way to organize my talk is according to people. So I'll talk about some of the people that I've met. Maybe to clarify, so one person in the list is myself. And to clarify, forensic mathematician, yeah, I'm definitely the foremost in the world, but that goes along with being the least most. There's only one person who's actually claimed this professional description. And that may be because I'm an imposing figure and I scare people away. Every now and then I've had a letter come from some perhaps fledgling student in China wondering how to become a forensic mathematician. And I usually say, well, wait until I die. Now, I've been a mathematician by inclination at least since first grade, with some interruptions, because life is by its nature chaotic. But anyway, by the time I started university, I certainly was thinking in terms of mathematics, and that was at Stanford. And at that time, there was, of course, well, not of course, but of course, if I tell you this was in like 1961 that I matriculated, there was no such thing as a computer science department. It was soon to come. One of the mathematics professors there was Forsyth, trying to remember if his first name was John. That's not quite right. And he became the first editor of the ACM journal, American Computing Machinery or something like that. And he, in fact, introduced me to computers. Stanford had one computer in those days, and eventually I had access to it to do things like play games or write little programs that were, of course, not in APL. But I did have the opportunity, even very early on, to meet a couple of APL pioneers. To be, of course, to be. One of them was Larry Breed, quite an interesting guy, a man of many sorts, a Renaissance person, and a left-hander. And I first met him when we were both in the computer make-ready room, and Larry asked me to wind his watch for him. And the excuse was that his left hand was in a cast, and the watch was in his right hand because he was left-handed. and it needed winding because that's the way things were in those days. But as to why you would ask a stranger to wind your watch, that's not clear to me. I guess we'd seen each other around. He was upperclassman, and I was maybe just about to start my freshman year, something like that. Anyway, he was a bit older. And so I dutifully wound his watch, and as a bonus, I set it for him. It was off something like 6 hours. It's hard to say exactly how many hours it was off because on Larry's watch, the minute and the hour hands were not synchronized as they normally are. They wouldn't be both together at a 12. They would be both together at a 6. So Larry took advantage of my, actually, as I learned decades later, falling into his trap, and scolded me for setting the watch, which was perfectly set as far as he was concerned, because of course he didn't look at the numbers, he looked at the positions of the hands. And for a right-hander's watch on a left wrist, everything is, the numbers are upside down, so you have to ignore them. Anyway, so some years passed while we all learned about computing a bit. And another person there was Roger Moore, who was a prototypical redhead, quite a temper, Roger, little guy, and apparently a bona fide genius. And what I wasn't very conscious of, I knew that Roger was largely a mathematician. He was a graduate student, and Larry told me an anecdote, so I made it clear. But the fact that Larry Breed was academically a mathematician wasn't clear to me until maybe when he died last year, or maybe I'd forgotten things along the way. But there's a tendency for mathematicians in the APL world, and typically by mathematician, I mean somebody that has a rigorous approach to reasoning. So I certainly include a number of dialogue folks who don't necessarily include themselves. Anyway, eventually I managed to graduate, and Larry, in the meantime, had moved over to IBM, and this would have been, well, when I graduated, it was 67, so Larry had already been at IBM Research Center, a beautiful building designed by a famous architect named Saarinen. And this was on the Yorktown Heights campus, which is a city in the northern part of the county that's just above New York City. What is it? It doesn't matter. So Larry invited me to come and work at Yorktown Heights at the IBM Research Center for the summer, the point after which I planned to go to graduate school. And Larry, and that was a very great privilege because Ken Iverson was there. He was the head of Larry's group. And Ken was a former Harvard professor, and of course was the inventor of APL, which from his point of view, initially was just a concept. He wrote a book, as probably everybody here knows, called A Programming Language, and which remarkably lent its name to the language. And some colleagues, older colleagues of Ken, were also at Yorktown Heights. I think that, boy, I'm losing track of names. There was one who didn't have a reputation for being so good-natured, Aiden Falkoff. I think Aiden, I mean, he was must have been a nice enough guy, because I believe that he and his family loaned me their house for house sitting the first week or so that I was in Westchester. But he was a bit grouchy, and not as talky as Ken was. And then another person was Eugene McDonald. And an interesting thing about computer work in those days was that there were no professionals to begin with. For example, the first boss that I had in computers, which was when I was in my last year of college, was a fellow who his major was English in college. And I think Eugene was similar. He was a member of a Jane Austen Society and a man of many sorts, although certainly he thought very elegantly about computer programming. So I had the privilege of coming into this APL group at a time when APL was in its infancy, and Larry and other colleagues have put together an interpreter that ran on the IBM systems of the day, which was there was an IBM system called the 360 series, which was many different computers over the years. Oh, and I have to tell you the story as best as I can remember it of how Larry got recruited by Ken. Larry somehow learned of the existence of APL through a pamphlet that Ken and Aiden had written, which was using the notation, which was just an academic notation in Ken's mind originally. I mean, it had subscripts and symbols over other symbols and things that still are not supported in real implementations of computers, never mind whether APL or not. But they have put together this book that explained exactly how a 360 works, down to the bit level, how it does a floating point divide, for example. And Larry applied, somehow he met Ken, maybe in the course of applying for a job, and pointed out an error that he had found in this book. And so Ken said, "Just goddamn breed, why didn't we find him sooner?" So he knew he had to find the guy. Anyway, I got there at the beginning of the summer and was put to work eventually. Maybe transpose and rotation hadn't been implemented yet, or maybe I re-implemented them. I don't remember. I remember particularly with transpose, maybe with both of them, but with transpose in particular, it's kind of a complicated thing. Of course, it's a matter of you have an array, which might be more complicated than rank 2. And depending on the left argument to the transpose, you're going to have to rearrange the elements of the array in a rather fancy, according to a rather fancy pattern within linear memory. And so how to do that before I started writing code, which in those days was assembly code. I modeled the process in APL. It was, of course, a clumsy language compared to what we have access to with dialogue, but still, it seemed elegant to us in those days. I caught on quickly. I don't mean I caught on quickly to being an APL programmer, although I may have, and that I caught on to the culture.
Surely you didn't use transpose in your model, did you?
Oh no, I couldn't. There was no I don't think there was a transpose. So I wrote a defined function called transpose. That's all I mean. And I didn't think anything particular of it, but Eugene noticed this, and he very kindly wrote about it later as, I guess, maybe as if it were the invention of modeling this kind of work before actually doing it. So, so then we had that. Now, Roger Moore was involved as a consultant there. And Roger is a bona fide genius, or he was. Roger died a year or two ago. He was a guy who clearly understood computers as if he were he was so-so with people, but he had an absolute gift with computers. It was like Ramanujan, the mathematician, famously was personal friends with all the integers. Roger, some years later, when I had been sort of hiding out in London, and eventually I needed to get a job, and things weren't going so well at the casino, at the card table. And that brought me back to America. I was for a month in Boston for training on how to use some computer called the IMLAC. And I thought it was very interesting because it had a graphic capability. And I invited Roger, who was in Toronto, to come down so I could show him this computer. And I found it was hard to show him because he came down on the weekend and I could gain access to the building on the weekend. But the computers in this building were password locked.
What was this computer called again, you said?
IMLAC, IMLAC. It's a clever name because it sounds like AC means automatic computer, like UNIVAC and other words of the day. But in fact, IMLAC was a character in a book by Samuel Johnson, the inventor of the English language dictionary in the 1700s. So now I knew by that time, I knew all the commands of the IMLAC. Like the number 17 is how you move a number from this register to that kind of thing. And Roger just knew computers in the abstract. So we stepped through the program step by step, and Roger would say, "Oh, I see what's going on." I would tell him what the name of the command was, and Roger kept up absolutely. And pretty soon he could see that we were about to go through the password filter, and he told me to jump around it. So we jumped around it, and I was able to show him what I wanted to show him. And there are many stories of Roger doing these things. Maybe the most relevant one is when some IBM sort of mini computer came out. You might call it the first such. I forget the number of it. And within less than a week, Roger had the APL interpreter running on it by emulating some other machine within this mini computer. The other project that I hear about occasionally, which I had something to do with, I was an APL 1130 interpreter. APL 1130 was an IBM machine that I guess was intended for accountants or something like that. And for some reason, Larry decided to implement APL on it before I got there, and the project just sort of died. And in order to keep me busy, he assigned me to try to resurrect it. So eventually we had an APL 1130 interpreter that ran. And the most memorable part of it was a triple shift keyboard, which I designed because I needed more keys than were available with only the normal keys on the keyboard in the single shift. And I don't know whether it was more appreciated or despised, but it's certainly an awkward thing to have to put in an extra ad hoc shift key just because somebody doesn't give you enough keys to begin with.
So you added another key onto the keyboard, a physical key onto the keyboard?
Not physical, no. I appropriated one of the keys to be an extra shift mode.
I see.
And presumably this wasn't an alphabetic or numeric key.
Probably not.
Yeah, I guess it could have been. You could say you could use the same key for 1, 2, and 3, just depending on the shift mode.
Yes, of course. So I suppose you originated this modern thing that we take one of the keys from the keyboard, like the backtick, and use it for an APL shifting key or prefix key.
I didn't know we do that.
Well, yeah, in some of our environments we do that. So now we know who invented the notion.
Well, maybe it was invented more than once. Anyway, I stumbled on it. Oh, and another thing about modeling. I want to talk about modeling. One of the really nice, a lot of things. So it ended up that I stayed, that my summer before graduate school was something like 8 months long. It was just too good a job to walk away from. And I wrote to my prospective graduate school, University College in London, and asked if it would be okay if I deferred until April to come over. And they said yes, but only once. So I continued working with Larry and the group, and a lot of it was that we had very free hours. I think I rarely would come in before 11 o'clock in the morning. But afterwards, I'd typically go over to Larry's house where his wife would cook us dinner. And Larry and I would lie down and or lay out some work on the carpet in the living room, which could be going through step by step some piece of code that Larry thought we should understand. And of course, the guy who was the incredible proofreader that Larry was very meticulous about every single digit, why it was there and what it was doing. And one project that I remember particularly, Larry decided that it was important to understand how a certain piece of IBM machinery worked. I think it was essentially a forerunner of a modem. I mean, it was a huge thing, but it had wires going into it, and it was the interface between our APL interpreter and the school students or even college students around, mostly New York, but in New England, so that they could sign on through telephone. And so there was this, and he really had wonderful IBM documentation in those days because it would tell you what's really going on. Circuit diagrams, page after page of circuit diagrams. And so Larry got me involved in watching him figure out how all the bits worked and the protocols, how the machines have to send each other signals, an awk, for example, and acknowledge, which is, I think it's actually a symbol in the ASCII code. So, but eventually I had to, I'm sorry, I wanted to mention one other model. So I leveraged APL to write some poetry. And it's poetry. The nice thing about poetry is poetry is whatever you call poetry. So what the program actually did was you fed it, you trained it with samples of language. And all it did was to randomly pick trigrams. So it would look in the sample and it would find, and it would pick a point at random, and that letter and the two subsequent ones would be the beginning of the poem. And then it would take the last two letters and look for an instance of them in the training dictionary. And the first such that it found, it would take the letter that followed them, and that would be the next letter, and so on. So the way this works is it tends to give you something that you can at least pronounce in English, because any three-letter string definitely makes sense. And what remains of it is a couple of words that I kind of liked. One of them was Gudello, and the other was the phrase anticoprerency. But I never was able to publish this. But the nice thing about working for Ken and working for IBM was that I could do this work and be paid for it as long as I wrote it up at the end of the month as the explanation of how the month had been spent.
You don't have any of these poems lying around?
Well, I just remember those two phrases.
That's
And
too
a
bad.
good friend of mine and I still greet each other by saying Godello.
Nice.
When his wife had died, I said that, and he said, "You always make me laugh." So it paid off in the long run. Eventually, as I say, I went to London, and after some years there, not actually having fallen out with mathematics, sadly, and not doing very well with either English or the card table, I came back. The coast was clear. I'd been evading the draft those years. And despite all the bad things that I had said about Richard Nixon, he forgave me. And I was in the clear, and the FBI was no longer on my tail. They really only wanted Muhammad Ali. The rest of us could go free. So I looked around for a job and got in touch with Larry Breed, and he was a vice president at that point of a company called STSC. That's now APL 2000, I think. And so Larry suggested that I go see our friend Roy, who was working at the STSC office in LA, where I had taken residency, because it's warmer than London, you see. And I mean, that was the only thing wrong with London. It was a great place to be in the years that I was there, from 68 to 74. But so Roy Sykes was one of the managers, I guess, in the LA office of STSC, and he interviewed me. And after he gave me an actual coding problem or two in APL, about which I was at a minimum 6 years behind, he decided that I wasn't needed. And I talked to Larry, and he said, "Oh no, what I meant was that Rory could have you half the time and I'd have you the other half the time."
Wait, which year was this, you said?
68. I was back in the US in 68.
So,
Back in the USA, Chuck Berry.
right. But you said you, with regards to APL, you were 6 years behind, but had a lot of changes happened to APL from 62 to 60, so from right when it was new to 68?
From 68 to 70. I may have gotten the 68 is when I went to London, so I lost track of APL.
Oh, okay.
And 74 is when I came back.
Sorry, my bad.
And maybe that it's better to say, maybe I was just rusty, you know. But in terms of program development and being used to using the language and developing tools, for sure. And Roy had a lot of application experience, and I had probably exactly zero, as probably Larry did, exactly zero. You know, we were working out of imagination, not out of experience in the things we built. But Larry rescued me, so I worked with Roy, and eventually we became friends. Well, I mean, he's an easygoing guy. We were friends from the start, and I got to go to the East Coast and work with the development group, system development group, a bit. And one of the projects that I was assigned to, Larry thought that we should have a customized transpose implemented for Booleans. Now, the Boolean representation makes obvious sense when you're dealing with memory that is precious. When I finished my undergraduate years, that we had this amazingly enormous UNIVAC computer with if you can believe it, 1 million bytes of memory. And which cost approximately $1 each. And of course, with a machine like that, you're still doing things like using one-letter identifiers because you need the space and dumb stuff like that, and garbage collecting more than once a week. Now I only get my garbage picked up once a week. And so it just occurred to me to wonder just a few minutes ago, if this Boolean representation really makes sense nowadays, because it's very clumsy. The raw hardware does not have good commands for shifting bits around. And I thought I did that great work back in '74 or something to implement Boolean transpose very efficiently compared to what you might do. But is it really efficient compared to what you can do with byte storage? Well, I ask you to privately make your guess. Is it worthwhile saving bits as bits, given that you have essentially infinite storage available in a modern computer?
I know the answer. I guess that's
So you
cheating.
know the answer. Okay, all right. Go ahead. Tell me what do you know?
Well, I know that as fast as computers have become, the CPUs have run away from the memory. And so most of the time, the CPUs are sitting there idling, waiting for the memory to feed them work to do. And therefore, being able to pack 8 times as much data in the same amount of memory being transferred to the CPU is an enormous difference. It makes all the difference.
Yes, okay. I didn't know that. I mean, now that you mention it, it's something that I sort of knew, but I didn't actively know it when I started this. So I tried first an example. Well, I tried a few examples, and depending on the size of the data, the improvement from, I was comparing transposing pure alpha with transposing just a string of ones, or a complicated multi-rank matrix of ones. And when I got up to close to 1 billion items, the binary is going maybe a dozen times faster. If you have smaller things, it might be only twice as fast.
It should also be noted that at least today's processors have lots and lots of instructions dealing with bit booleans. So it's not even as clumsy as it used to be, because some things are built into the processors, but certainly for speed, it's essential.
Yeah, it's possible that the people who are designing the central processor knew about the limitations of the memory.
Right.
And so Larry thought it would be something to do. I don't know why. And he showed me at least one machine language instruction which is useful for bytes. I've never really understood it, but it's called test, and I forget what it's called. Test and transpose. Anyway, it gives you sort of a way to inspect one bit at a time. And so he taught me this instruction and said that's the way to do Boolean transpose. And so I wrote down a few instructions of code that basically did it. And then to make it go faster, I unraveled a bunch of loops. Like you want, instead of having one way of picking a bit out, which has a parameter that can specify whether you want the leftmost bit or the second bit or the third bit and so on. I wrote 8 different copies of it, each one customized for a certain bit position. And then I doubled 8 to make 16, depending on whether your next bit is going to cross one boundary or 0. And in that way, I had something that always reminded me of a Ferris wheel. And I was very gratified when a friend of Larry, somebody who Larry spoke of in terms of awe, another colleague of Roger Moore, good Lord, a good friend of mine now, although I haven't seen him since the last time we were at a APL meeting which for me was 3 years ago. Can you help me, Adam? The guy, he's from Toronto, and he's on Snake Island.
Bob
Yeah, Bob
Benecki, right?
Bernecki, thank you. Sorry, Bob. And so Bob very kindly said, when he saw my code, he said, "Oh, you must be doing something I hadn't even thought of," which I thought was very kind. He apparently had implemented a Boolean transpose himself.
So you would pad, I suppose, if something didn't line up with 8-bit sizes, you could easily have an array that a Boolean array that is not a multiple of 8 bits. Then you would pad it first to a multiple of 8 bits, and then transpose and then chop the end.
I don't think so. I think I just figured out, I mean, typically, I'm going to accumulate bits. The plan is that I'll jump around on the source matrix and collect the bits in order that I want in the output matrix. So I'll be building the output matrix in linearly, sequentially. And so but the source from which I'm collecting bits is going to be within a row. I'm going to be collecting bits that are, let's say, 17 bits apart.
Yeah,
So I'm going to jump by 16, 17, and sometimes that means crossing one more boundary than other times.
Right.
That's the best I can remember. I did not retain the code myself. I do remember that STSC had a policy that you had to do some quality control. Somebody else had to look after your code and agree that it looked reasonable. Maybe we even had to do an active test and see if it gave right answers. I can't remember. And so there was this other kind of amazing fellow who later became a primary force behind the electronic computer. What's it called? It's sort of a libertarian attitude about computing.
Richard Stallman for the Free Software Foundation?
Maybe that's the right name. His name is, again, I'm forgetting the name, John. He was number 4. He was the first paid employee at Sun. He was number 4 at Sun. The first 3 were the founders. And another Roger Moore level person in programming, a little more sociable than Roger. John was maybe a cross between Larry and Roger in that respect.
So there were 2 Johns involved in the Electronic Frontier Foundation. John Gilmore, John Perry Barlow. Gilmore?
I mean Gilmore. Yeah, Gilmore.
Okay.
I think he still lives in the Haight-Ashbury, although I haven't seen him in some years. So John took a look at my code. He was assigned to look at it. And I remember he commented that my comment seemed more designed to want to tickle somebody's curiosity rather than to explain what the code actually did. So many years later, when I had suffered so often from trying to understand my own code that I wrote 2 years ago, I often remember what John said and tried to do better. I don't really care if other people can understand my code, but I need to. So in that respect, it was a great relief when I learned at some point in the 90s that APL decided to discard their principles and include control structures. Compared to what Ken Iverson wrote, ifs and fors and so on just violate the spirit. I'm not saying Ken ever said that, but that was what I absorbed. But in fact, every now and then I look at my 30-year-old code and I see, or at least, yeah, 30, even 30 years old. And I see where I did a, what would you call it? A synthetic if-else construction. And it's just very annoying and hard to read code.
Yeah,
when
my
it's
father
after-
taught me all those techniques as I learned APL without control structures. And
Oh, your father?
yeah.
Did you say? Oh, I didn't know your father was your source.
Oh, sure. Yeah. That's how I grew up with APL. And yeah, he taught me all those techniques of how to write if and else and for loops and so on, and always do it a check at the top, because otherwise one day you'll hit an issue where you want to skip the loop altogether. And yeah, it's you can understand when you write it, and it's really annoying to read afterwards. So I can definitely resonate.
Absolutely. And another thing that I don't see how I could have done without is a dialogue's business of auto indenting. That's just wonderful. So anyway, I had to come back to the US in, let's see, no, where am I? I came back to the US. I did some of those things. I met Roy Sykes. Roy taught me how to write fast code. I think he's still faster than me. I always thought at Stanford, I was the fastest. But, and the weird thing about Roy, by the way, is that unlike all these other people, he doesn't have a mathematical background. And by that, I mean, when he writes mathematics, he actually uses APL notation. He does not assume the normal mathematical hierarchy of symbols.
That's very nice. But do you know if any of that material is available anywhere? It would be nice to see original mathematics expressed as APL, not something that's been translated to APL.
Well, Roy is around. I haven't talked to
Yeah.
him for a while, but he's not far from here. He's an hour by plane, and we're now allowed to travel again. I should certainly pick up the phone. And I should, let's see, I think I wanted to make some comments about current days, so I'll just wrap it up. It came to the point where I had to start learning Windows to write programs for Windows, because Microsoft stopped supporting a platform that lets me run STSC APL. And
For the youngsters out there, that's DOS.
DOS, yeah.
The new DOS, not the old DOS.
There's a new DOS?
Well, Microsoft DOS or or MS DOS or licensed to IBM as PC DOS, but there was the old one on IBM's mainframe, so it was also DOS.
Oh, I
The
see.
disk operating system.
So in 2006, maybe among other times, I went to an APL conference, which was an APL 2000, and I had a good time and met a few people that I'd known from earlier years. And I didn't realize that I met Morton there, but it worked out very nicely. I mean, you all know Morton, and he's another polymath. He's a man of many sorts. And he had the effrontery to call me up out of the blue and ask if he could help. And I say effrontery because Morton is one of these people who's so tactful that, he would give you money and ask you if it's okay. Well, so that was very nice. And I certainly so as a result, I got enticed to dialogue. And as you probably know, Morton's motivation, sincerely, is not to take customers from a rival, but only to take customers from a rival that he thinks is not religiously pure. And he didn't feel that, so if other companies that he thinks are doing dialogue, that are doing APL in the right way, Martin will support. And as a result of that, I met, well, for one thing, Morton, and also Adám, who obviously has a very rigorous capability of thinking about problems, which is something which alludes to mathematics. That's what I'm talking about. But more explicitly, John Scholes. It was obvious to me from the first time I met John at one of the dialogue meetings that he is mathematically inclined, and so I wasn't so surprised. I mean, I'm always surprised when I'm right about something and I prove to have guessed right, but Scholes majored in mathematics at college, and he invented this beautiful defense stuff. Actually, I just learned that he didn't exactly invent it. He developed it, but the concept existed in cruder form already. And so I managed to accumulate by osmosis some of the style that John implements. And another person that very much worth a mention, who also very sadly died in recent years, is Roger Huey, who was a close friend of Ken Iverson going way back. And don't want to end with a Ken anecdote, so I'll mention it now. I had inter alia a chance of consulting with IP Sharp at some point, and Ken Iverson was there at the time. So this was some years after I worked for Ken at IBM. And by the way, a very good trick that I learned from Ken is always take a nap after lunch. At IBM, you mustn't knock on Ken's door after lunch. So I recommend that highly. And when I saw him again, or was delighted, but just by chance, I was visiting Toronto and the IP Sharp thing, and the elevator door opened and I was in the elevator, and Ken got into the elevator, and apparently he had made sense and overheard of what I'd just been kvetching about. And Ken said, "Oh, you hate Carl Sagan? I thought I was the only one that hated Carl Sagan." So I won't tell you why I hated Carl Sagan, but the important thing would be why Ken did, and I don't know. Anyway, Roger, as you know, was a friend of Ken's, and he put together all this amazing stuff. And he denied being a mathematician when I early met him, but he's a liar. Roger is very much a mathematician. And I was working on some code for a practical project that I've been doing for quite some years. And I found a way I needed to do some geometry in arbitrary numbers of space. Well, not too arbitrary, but somewhere between 1 and 6 dimensions. And I didn't want to work with rectangles or their generalizations to higher dimensions because it would be too complicated. And I realized that I wanted to work with simplexes, which are simpler, but they're not regular. And I was afraid of that. I thought, now I'm going to have to go to Switzerland to find this mathematician that knows how to do this complicated multidimensional geometry. But luckily, before I booked a ticket to Switzerland, I learned that you can compute the volume of a simplex. By a simplex, I mean the generalization of a triangle or a tetrahedron. And it turns out that the volume is simply a determinant. It's just the determinant of the vertices. And well, to write a determinate program would be the work of an hour or two, I suppose. It's not a big deal. And then another days in order to get it right and doing efficiently. Or you can just look in the defense list and you can see that it's already done. And then you can find out that Roger Huey did it. And then you know there's nothing more to do. It's perfect. I think I'll stop there. That's good enough.
Oh, I mean, feel free to continue anything you want. By the way, interesting. I just looked at that very recently, the determinant function in defense workspace, because there was somebody who implemented a new algorithm, just came out a few years ago. Some people devised a divisionless algorithm for determinant.
Divisionless, but is
Yeah.
there division anyway?
Yeah,
No,
there's,
there's no division.
I
You
think
just
so.
multiply and add.
Well, it depends how big, hold on. Let's see if I can find it. Yeah, there's a division. There's a division going on. For big matrices, you have to. Well, you don't have to clearly because there's another algorithm that doesn't have it. But I implemented it and I tried to do some timings and to see which one is faster of that. But it depends. Depends on what kind of matrix you have. Which one's is faster. So maybe maybe whatever Roger wrote is the fastest. Maybe you're right.
Well, yeah, maybe you could do better than Roger. I mean, it's fast anyway.
Oh yeah.
In
Sure.
terms of bottleneck in my program, it never became an issue.
I believe you. A couple of questions I have for you for people who have been writing in the chat meanwhile while you've been speaking. For those early computers you worked with, so I suppose the 360 at IBM, how much memory did you have to work with?
Oh, I don't know, but let me go back to the first one. It was the IBM 650. That's what I learned from, that's what Stanford had when I was in high school. And it was a decimal machine. So the numbers were 10-digit decimal. And we had something like 2,000 words of memory. It was on a drum. Then when I was graduating in my senior year and we had the UNIVAC, I mentioned that it was 1,000,000 bytes. The 360, I guess the 360 came after the 7090. So we had an IBM 7090 at Stanford before I left. And I'm thinking, I don't know, it must have been comparable to the UNIVAC, which was at Lockheed, where I had a part-time job. And simple answer is I can't remember for the 360.
That's okay. That's a valid answer. And also, Jerome is asking, what were the typical APL 360 customers back then when you worked with it?
Well, maybe I can remember who they were at STSC, which would mean in the 70s to 80s. APL made big inroads into what are the mathematicians who work for insurance companies called? Starts with A.
Well, the accountants, actuaries, no?
Actuaries, yes.
Yeah.
Yeah. And in fact, our friend, there's a couple of brothers that we see at the dialogue meetings, and one of them is a statistician.
Oh, yes. The Mansours.
Mansours, yeah.
Stephen Mansour is the statistician, and Paul Mansour does database stuff, I guess.
So Stephen, I would say, is roughly speaking of the really getting senile of the group that I was trying to remember the word for.
Yeah, the actuaries, which were
Actuaries, yeah.
common, a common application of APL, I guess.
Yeah, in fact, I worked with an actuary in the LA area as one of the applications that we were supporting when I was working for STSC. And where else? I think actuaries, at least I think there's descendants of actuaries and APL working in financial institutions today, like JP Morgan.
K has largely taken over there, but it's an APL descendant, you could say.
Exactly, yeah.
Okay, well, so far so good. And we are getting up on the hour mark, but you've got to say something about forensic mathematics using APL, no?
Oh, okay. Well, I was doing freelance computer programming for a while, And finally, I came across an application that was very interesting, which involved learning genetics. A friend of mine from college days had ended up being a pathologist, and he ended up running a paternity lab. And that meant deciding if men are the father based on genetics. And that was before DNA. So he taught me some genetics, which is really interesting stuff. And then DNA came along, and on the one hand, it meant that some of the most intricate parts of genetics are no longer necessary. DNA is simpler.
So what was genetics, which is not DNA?
Well, it's the products of DNA. In the 80s, we didn't have DNA typing, but we did have various enzymes and proteins in the blood, which are polymorphic, which have different varieties. And based on whether you can see the commonality between the alleged father and the child, you have evidence that he is the father.
Okay.
For example, ABO blood type. That was the first one. That goes back 100 years. Charlie Chaplin was, by the way, excluded from paternity due to his ABO type, but nonetheless, in a sort of rough justice, the judge decided that he should pay.
Okay, so it was genetics based on phenotype, not genotype,
That's
because
right.
you didn't have it available. So you see who has blue eyes and who has this type of blood and so on.
That's right. And then gradually, this genetic business became more and more important, especially as the DNA came along. And there was some glamour to it. When the O.J. Simpson trial came, there was a very attractive young analyst who testified against him from Berkeley Lab. And statisticians wanted to get into forensics because they thought they had something to offer, and population genetics thought they had something to offer. And so, like I say, it was a romantic undertaking. In some cases, what they offered was complication and maybe a professorship for themselves. But anyway, I managed to make enough of an impression that I created a field called forensic mathematics within DNA analysis for identification. And it turns out that there's a lot of fun stuff. In the first instance, it was essentially combinations, combinatorial, and probabilities. As I say, these compared to the proteins and enzymes, DNA is very tractable stuff, numerically speaking. It's like an integer combination lock. The wonderful thing about the genome is that it's so diverse. It's like the different continents of the world. There's places in the genome where you have monotonous strings of repeating the same four base pair motif. And there's other places where you just have tons of crap that nobody could ever love. So basically, we stick with the systematic part, and you just count how long it is, and you see if the father and the alleged father and the child have the thing of the same length. And then some more interesting and complicated problems came along over the years. And so for the last 8 years, I've mostly been thinking about how to deal with touch DNA, which, I mean, sadly, it's no longer purely an integer problem. It involves continuous functions, not just discrete ones. And if you had asked me when I was in college, how do I feel about integration as opposed to combinatorics and number theory, I would have said I'll take the latter. And in a way, that's still true, but I think I have a very elegant discovery in terms of numerical integration.
But that's your proprietary information, I suppose.
That's what? No, well, I have, in a way, yes, but on the other hand, I would look forward to giving a talk on it to Dialogue,
Sure.
Where I don't think the audience is going to be overrun by people who were competing with me on touch DNA analysis.
I think it would be a very interesting thing to hear. I mean, this is my personal opinion, but I often think at our user meetings where users are presenting their use of APL, they very often give this high level thing of organizing this project they're doing, whereas the audience, they want to see some code.
Mhm.
They want to know how this is actually done. So yeah, I think that would be largely popular. And enough of all that business stuff around. Just get to the point and show us what the APL looks like.
I
So yeah.
hope so. And it fits in my reason for coming to APL conferences and talking is that I want to, I want help. I want people to be interested in what I'm saying so that they'll be interested in me and my projects and come and talk to me about it and offer assistance.
Yeah. Well, definitely an idea. I think let's take that up for sure. Okay. Well, this has been great. Thank you so much. Let's see if anybody has any other questions in the chat. No, I think we covered everything. Otherwise, speak up if anybody wants that.
Well, I'll be happy to talk to anybody by email or even telephone if you wish.
Well, if anybody wants to get in touch with you, and also for the viewers of this later, then I'm sure they can find a way to get in touch with me, and I can forward. Oh, so Rory is asking here. He's asking if there's anything else in your code. So obviously your code has a lot to do with these genetics, but there might be things that could be generally useful. You must have had opportunity to develop a lot of utility code, general purpose code that you use all over the place that might be something you would want to share.
Oh, well, yes and no. I mean, I'm perfectly happy to share it. And of course, I had to put together a whole bunch of tools before I felt comfortable using dialogue or using anything. Well, of course, because I'm not sensible enough to learn somebody else's tools instead. In that regard, I remember a great comment of Adrian
Smith.
Smith, yeah. And let's see, what's his first, wow, another friend whose name I can't remember. Swain is his last name.
Rex, no?
Rex Swain, thank you. Yeah, Rex, not quite such a common name. So Rex is a very meticulous programmer, much more so than I am. And yet Adrian is another level above Rex. So Adrian, who's, I mean, he's not a sarcastic person, but he did make a sort of snide comment about Rex's helpful utilities. He said that typically for Rex, it's sort of 90% done.
So I see what you're getting to here.
Yeah. So mine is, yeah, who knows? My ideas are good, but it's not so elegant, my tools generally. I would be happy, where I feel an obligation, in fact, to give people some intro or understanding of a tool called INNO, which is a packager. I mean, I use it to make a professional looking installer for my code. It's free software, and there was certainly some learning curve to use it, and I'm far from an expert in it. If you really want to go deep, it has the capability to do anything you want with Pascal. Now, many of us think Pascal died 300 years ago, but apparently he lives in the life of some people. But anyway, it can be very useful. You can do a professional installer with it.
I mean, if you have utility code like that, so I think what Rory is getting at was that you might want to preserve your trade secrets. You don't want to give away all your algorithms that you do your living off. But the utility libraries that somebody like you that has, as professional that has been needing to do real work over the years have built up would be something that's not really a trade secret. It's just tooling, as you say.
Right,
And
yeah.
and even if you say that it's not polished and made ready like Adrian Smith stuff would be,
Mhm.
if it's something that you open up to the world at large to look at, then the community can step in and help polishing up things. As you said, you'd like to get people involved in what you do. So do not underestimate the power of the community to step in and help with things. But it needs to be out there. The code needs to be available for them to look at to be able to help with it.
Well, I'll give you one example just to maybe explain why I'm shy.
Sure.
I've long used a function called OR. And what OR does is very simple. The left argument is the name of a variable in quotes. And the way I write my code, often I want to refer to a variable that I may not have bothered to initialize.
Right.
So the right argument is the default value in case the thing doesn't exist. It's kind of trivial to write. It saves me a line or two of code here and there. I mean, many people would write this out explicitly every time they need it, like if times quad nc of such and such, then do this, otherwise that.
Right.
So it seems hardly worth, it's so trivial, it seems hardly worth contributing.
Yeah, but still, as if it's an entire library of stuff like that, and if it's a one-liner like that, or almost a one-liner, then it can often be. I don't know if you're aware of my Apple Cart library.
Oh yeah, yeah, I like the Apple Cart.
This particular function is there. The one for the default value with the name in the left argument as, or I think I take the name as the right argument, then the default value is left, but same thing.
I have two of them. A lowercase o is the flips the arguments compared to an uppercase o.
I see. Okay, well, there you go. So, but okay, it could be something to consider. I mean, you're always welcome to contact me if you want help with publishing some of this, even if it's not as polished as Adrian Smith's stuff is. By the way, he's coming in the beginning of the new year. He'll be a guest here at the APL Campfire. It'll be interesting.
It will indeed. He has a lot to say.
I'm looking forward to that as well.
And I'm glad he's still saying it.
So now we have that on the record. You're welcome to contact me, and if you want help with putting some of your stuff out there for the community to look at, and for the people watching this, you're welcome to contact me if you want to get in contact with Dr. Brenner to hear what he does, or otherwise be in contact with him. So I want to thank you so much for giving away this hour of your time. Really appreciate that. And I hope that other people watching this will as well.
Thanks, a pleasure, and nice to see you. I mean, everybody I can see, and the names as well.
Thank you. Bye.
So long.